The machine comes with 5 different welding modes. The first and the most important, of course, is the two-sided pinch welding liquid-cooled clamp. We also have a single-side welding mode if we're only able to weld from one side and can't reach behind with the electrode tips. When the machine is in the setup mode, we need to tell the machine what arm set we've installed on it. Now these are 120 millimeter arms here, so we're looking at 120 millimeter arm here so that we can predict the amount of squeeze pressure. As the arms get longer, like these, the available pressure will drop and we may need to adjust here on the gauge. So each arm set is stamped with an identifying number, and we scroll through the setup until we come to that number. And now we have a different prediction of pressure. We may need to adjust this up in order to give us enough tip pressure out here at the end. The machine is equipped with a 2-stage trigger that's going to allow us to squeeze, weld, and then hold. It has an auxiliary button on top here that allows us to open the jaws wider if we need to reach around a wider opening. What we're going to do is make this a 3-step process where we're first going to squeeze, then initiate the current here, weld, and we're going to hold for 3 seconds until the beep on the machine stops to form the weld and let the weld cool while it's still under pressure. So we'll activate the air. We're going to squeeze, then weld, and then hold until the beep stops. And the weld is cool enough that we can touch it right away. All right. Let's talk just a minute about tip alignment. If we're going to change out the tips or adjust the arms so that we get them aligned, so that we get a nice round weld nugget like this, the tips are going to have to align in both planes, both this way and this way. If we're adjusting them, we want to turn off the cooling system so that no coolant leaks out when the arms are being adjusted. We can disable the current here. So now we can close the jaws to see if they align without accidentally welding the electrodes together. When we replace these tips, the little dot on the tip aligns with the hash mark on the arm. And again, we only do this adjustment when the machine is turned off so that no coolant, which is under pressure, sprays out here. The machine comes with a full range of dent pulling functions. The most common of which is dent pulling with nails or studs. We have a separate mode for that and 4 memory slots, so we can program in both a current setting and weld time setting for each of the functions that are on here. Here we have trim rivets, welding with nails, dent pulling nails, wiggle wire, or quick dent pulling with the star washer. So the first application is going to be a nail. We've set this at 25% power and 60 milliseconds, so we can put a nail on very tight and strong but not burn the panel. This takes place very quickly in less than 1/3 of a second. We've put the nail on there strong enough to pull without burning the head or burning the panel. The slide hammer comes equipped with a stud puller, has a little eccentric wheel in the end that we slip down over top the nail, and then pull it, exerting pressure in this direction. We would pull, and then when we're done, we'd like to be able to twist that nail off clean without any metal transfer or without having to cut off the head of the nail. A faster application is to dent pull with the star washer on the end of the slide hammer, using a similar setting. And I've got this in memory slot number 4 because it appears in the 4th position here. I can work 10 times faster than I do with nails by welding on the star washer. Pull, twist. This process is going to be 10 times faster than nails, and each one of the points on the star can be reused between 120 and 150 times. So one 3-pointed star will take the place of 450 to 200 nails. If we have a deep groove or long groove in the panel, a dent that we have to pull out, instead of applying 10 or 15 or 20 nails, what we will use will be wiggle wire, which we can bend in the same shape as the dent and cut it in lengths that are appropriate for the dent, and then weld it on using this electrode. That function is also here under dent pulling. We have it programmed under memory slot 3 because that's the order in which it appears. And we're going to apply just enough heat and weld time to put this on tight without burning the panel. Again, we're going to go to our slide hammer. Everything interchanges on the head of the slide hammer, and we're going to install our pulling claw on the slide hammer. We drag it across the body to grab the wiggle wire, and with the slot that's in the fingers, the deepest part of the dent will be pulled first until it pulls out even to the body line. If we're in a real tight space, we don't need to use all 5 fingers. We could only use 3. And the idea is to have this on in such a manner that it's on tight for a tight pull, but when we take it off, it comes off clean so that no wire and no metal is left behind. On older cars, we may need to replace trim rivets. And we have a setting on there for trim rivets. We'd like to put those on tight enough that they aren't going to come off the car. So we have a little magnetized electrode. We're in memory slot number 1. A separate time setting and power. And we're going to let this burn on. And we'd like this to turn a little bit gray at the bottom because we don't want it to come off the car. We've supplied a tool to help tweak this so that we can adjust it to let the trim clip slide on there.